Welcome to Spring LIB.
All right, so here we have what appears at first sight to be kind of a tricky and involved problem, but really it's nothing but simple energy conservation and using the formula for rest mass energy correctly. So, situation is as follows. You have a helium nucleus, okay, with a mass of 4.0026 times U, which is the atomic mass unit, or roughly the mass of a hydrogen atom. And this breaks apart. You want it to break apart to two protons, okay? And so 2p, each with a mass of 1.00783 times U, which, by the way, contains electron mass too, but electrons are way less massive than protons, so it's pretty negligible. In addition, you have two neutrons, also nuclear particles. So 2n, each with mass 1.00867 times U, the atomic mass unit. Okay, so by energy conservation, you have that the rest mass energy of the helium, the rest mass energy of helium nucleus, which is m, the mass times c squared, will be equal to the rest mass energy of the proton and neutrons, the protons and neutrons rest mass energy. So that's mc squared, and two protons means 2 times mass of proton times c squared, and 2 neutrons means 2 times mass of neutron times c squared. Okay. And so the binding energy now, is actually energy difference between the initial and final conditions. And so this is just given as BE will be equal to the energy difference, right? Will be equal to, let's use a different color, 2 MP plus 2 MN minus M helium, all times C squared. See that I just moved the rest mass energy of helium to this side. That makes it the energy difference. And so we have 2 times 1.00783 plus 2 times, put parentheses there, 1.00867 it's a bigger parentheses there, minus 4.0026 all times U times C squared. Notice that I factored out the U because all of these masses are in terms of U, so it's much easier to just factor it out. Okay. And so what you get when you add this and this and subtract this from that is 0.0304 times U times C squared. Okay? And so your binding energy is 0.0304 times the atomic 0.0304 times the atomic mass unit, which is very close to 1.67 times 10 to the negative 27 kilograms, times the speed of light squared, 3 times 10 to the 8 meters per second squared. And so you work that out and you get something like 4.57 times 10 to the negative 12 joules. Now you can leave your answer like that, or you can write it in terms of MeV. And in order to do that, you just divide this by 1.6 times 10 to the negative 13 joules per mega electron volt. That's the conversion. And so the joules drop out, the MeV go up top, and you get 28.3 mega electron volts. And that's it.